Hi guys, it's your guy Olumide, and today we'll be solving another one of the most commonly asked tech interview question: find all subsets. It's a DSA problem that's commonly asked by top tech companies including Google, Amazon, Meta, Netflix, Microsoft, Apple, and other top tech companies. The problem statement states that return all possible subsets of a given set of unique integers. Each subset can be ordered in any way, and the subset can be returned in any order. We are given this example array. So it's an array of integers 4, 5, 6, and then these are the all possible subsets, starting from an empty set to a set of only a single element 4 to 4,5 to 4,5,6 to 4,6 to 5 to 5,6 and then 6. So we are asked to return all the possible subset of a given set of unique integer of an array of integers, so whereby the subset can be ordered in any way and the subset can be returned in any order. To solve this problem, we need to understand that each subset in the output is created by making a specific decision for each number in the input array, right? So, and that decision is that whether to add or not to add that particular number, whether to include or not include that particular number. For example, consider this subset 4, 6. We see that it is created from this input array 4, 5, 6 by including the number 4, excluding the number 5, and including the number 6. So similarly, 5, 6, the subset 5, 6 is created by making the decision to include 4, exclude 4, to include 5, and to include 6. Now let's see how it look like and what it look like to make this decision for each and every element in the input array. Let's consider this input array nums. So we're gonna start from the root node, which is the this empty list, which represents the root node, right? So now, according to the logic we explained the other time, that we actually create each and every subset by adding or removing a number, adding or including or excluding a number. So we're gonna start with that decision now. So starting with the very first number in the array nums, right? So now we have the decision of whether to include it or to exclude it. So now this is the decision we made now. So similarly, for each of these branch that we just create, whereby the first branch leads to this subset of 4, right, whereby we include it, and the second branch is actually empty because we did not include, we exclude it. So similarly, at each of these subset or at each of these branches, what we want to do is that we want to consider the next element in the input array now, which is 5, right? So now the same decision we're gonna make is that should we include or exclude it? So when we include it for this particular branch, this first branch here, when we know this is the first branch and this is the second branch here. So now when we include it into this subset, we have 4, 5, right? So but when we exclude it, when we exclude the second element, we just have 4. Right here on the other branch as well, when we include the number 5, we have 5, but when we exclude it, we still have an empty set. So we do the same for the third element in the input array, which is 6. So for each of these created subsets, which is 4, 5, 4, 5, and empty, we are gonna make that decision of whether to include or exclude the next element, which is 6 in this case. So now by including 6 into 4, 5 into this subset 4, 5, we're gonna be having 4, 5, 6. But when we exclude it, we just have 4, 5, right? So similarly for this one, when we include 6, we have 4, 6. When we exclude it, we just have 4. And similarly, when we include it to this part here, we have 5,6. That's when we include 6, right? But when we don't include it, we just have 5. We just have this 5. So, and similarly to this empty set, when we include 6, we have 6. When we exclude it, we have an empty set. And this way, you see that we have efficiently created all possible subsets just by, if we are able to traverse this tree in this way. So whereby we start from empty and we make a decision at each node of whether to include or to exclude the number. Now one challenge you have is, how do we get which number we are trying to make a decision on, which number we are trying to include or exclude at each node. For example, at this root node now, we are quite sure that okay, we are trying to include or not include 4. And when we move downward for each of these branches, which is this branch here and this branch here, we are keen on including whether to include 5 or not to include 5 along these branches. So how do we figure out which particular elements of the input array are we including or excluding at each node? To do this, we can use an index I to be a pointer to the current element that we are trying to make a decision on. So as we can see at this point, we have I equals to 0, meaning that we are making a decision currently on 4 along for this node. I mean for this root node, we are making a decision on the first element, I equals to 0. Then after getting into this new node, after moving to this new node, we are now making a decision on the second element. Sorry, here is supposed to be 1, y here is 2, y here is 3. So, and at this point, you see we are making a decision on the second element where I equals to 1, so which is 5. So a decision of whether to include or to exclude nums of I. So where and at this point now I equals to 2, right, which means the second element. So which means the third element. You know, I is 0 indexed. So 0 represents the first element, 1 represents the second, while 2 represents the third element. So, and then you see that by working on that, we see that when I go to 3, where 3 is the length of the is actually the length of the array, alright, you see that at that point it's going to lead us to all possible subsets that we can encounter. So we at the point whereby I equals to n, we actually have the final level of the tree, the leaf node that actually contain all possible subsets. And this is how we solve this problem. This is the logic to solving it. So, and backtracking is very good for this because we need to be able to backtrack, so, and as well as transverse this tree in order to get all possible subsets. Having explained the logic to solve this problem, let's go into the code implementation. Let's go into the code implementation for the find all subsets DSA problem. So we have the find all subset. So as our function name, now we're gonna be collecting an argument nums, so which is the list of the array of numbers that we want to extract all possible subsets from. So it's going to be a list of integer, right? So, and the return is going to be a list of integers. Why? Because we are returning all possible subsets. So now we are going to be defining a res, which is the output array. So results, it stands for results. So, and it's going to help us to collate all possible, we're going to be appending all possible subsets into it. As we are finding these subsets, we're going to be appending it into the res array. So now let's call the DFS. I'm going to call the function DFS, and what it does is that it helps us to iterate and backtrack to find all possible subsets. Now we are going to be passing in 0 into it, and this represents the row and the index, I mean, so it represents the current index, right? So don't forget, we'll be doing it at each index. We're going to be making a decision of whether to include it or to exclude it. so it represents the index. So this list actually represents the subset. Why? Because as we are actually we'll be appending elements into the subset, right? So as to create all possible subsets, and then we'll be passing our nums and the rest. So now let's define the function dfs. So I'm gonna collect that index as I, which is going to be an integer. We are gonna collect this as subsets. So the list as subset, which is actually a list of integers, right? So I'm gonna be collecting nums as a list of integers as well, and we'll be collecting rest as a list of integers, and then the return is going to be none, right? Because really all we are just gonna do here instead is that we are gonna return rest. So hoping that rest is gonna, at the end of by the time we call this function, rest is gonna contain all possible subsets, right? So we don't need to return anything from this dfs function, because it's just going to traverse the subtree. That's what it does. So now let's place the edge case, or let me say the best case, whereby we'll be returning. So whenever I become equals to the length of nums, so according to logic we explained, at that point it actually contain our subsets, the leaf node. If you go back to the logic, right, you find out that at the point whereby I become equals to length of nums, so we consider, let me put down this is the example we are given in the problem statement. So when I move from 0, it's index. So when you move from index 0 to index 1 and then index 2, and then it moves to index 3, which actually is equals to the length of nums, definitely it contains that particular, we just have to append that particular subset into our res outputs. So that's what it means, and by then we can simply return. So that's in a case whereby I equals to 3, right? So for this particular example here. So otherwise, what we're gonna do is that we want to add to our subset dot append the nums of I, the element at that particular index. We want to append it. So nums of I, and after that we call dfs so that we can traverse deeper, and this time we are going to be passing in I plus 1, because now we want to add, we are performing two conditions here, or let me say two condition or decisions, whether to include or not to include the current elements into our subset. So at this point we are including it. So similarly we are going to exclude it. So those two we are going to be performed, and the 2 is going to lead us to all possible subsets, just like you read you saw in the code in the logic. So at this point I added the particular elements, the current element, into the subset, and then I called dfs to traverse deeper into the tree. So similarly I'll be removing it from the subset dot pop. So this way we remove it from the tree, and at the same time, so this is the second decision, right? The second choice of excluding it. So this time what we appended at first, I pop it out, thereby I did not include it, and then similarly I'm gonna call dfs on it. So, and this is how we essentially solve this problem. So this way now is gonna include it and then traverse into the tree, and similarly after doing that it's gonna remove it, that is not including it, and traverse into the tree. So at each case it's gonna be adding 1 to the current index, so that it could make that same decision for the next element in the nums array. So let's run this function and see how it goes. Fine. By running it, we see that it gives us this all possible subsets, which you can see here: 4, 5, 6, 4, 5, 4, 6, 4, 5, 6, 6, and empty, right? This is it right here. So, and these are all possible subsets that we can extract from this input array 4, 5, 6. So this is how to solve this problem efficiently, and I hope you do understand. If you do, kindly subscribe to my YouTube channel and like, comment and share. Thanks.